And so the first thing that we're going to look at regarding quadratic functions is how to graph them. And there's a number of different ways that you're going to be asked to sketch these graphs or graph them. Okay. First of all, a couple things to be aware of. Okay, so quadratic equation written in, or quadratic function written in standard form is going to look like the following. It's going to be y is equal to, and you'll write your highest powers of x reducing down to your lowest powers. Okay. So this is the standard form for a quadratic function. Again, standard form has a definition in many different categories. So this is the standard form of a quadratic function. Okay, when you sketch a graph of a quadratic, right, a couple ways that you can do that. And so here's an example of a quadratic function. Okay, when you sketch the graph of this, the graph is always a parabola. Okay, what does it mean? You guys have heard that term. A parabola is what shape? U. Okay, and so the graph is always going to be U-shaped. It's either going to open up or it's going to open straight down. And that's always the case. Right, if the graph opens up, the very lowest point is called the vertex. And technically it's the point where the graph changes from decreasing or moving down to increasing and moving up. Okay. If your graph is a U that opens down, then the vertex is the highest point. Regardless, this vertex is called, or this point is called the vertex. Okay. So again, it's, let me rewrite that. Okay, the vertex is the point where your graph changes from increasing to decreasing. Again, the easiest way to think of it, it's the lowest point of a U-shape opening up, and it's the highest point of a U-shape opening down. And the other way that these might be referred to as is the lowest point might be called a minimum or relative minimum, and the highest point would be called a maximum or relative maximum. Okay, and so you'll be asked to identify these different things, so I just want to introduce the terminology. Okay, when you sketch the graph of a quadratic function, what you're first going to do is you're going to find the vertex. Okay, and the way that you find the vertex is you'll use the following relationship. The vertex can be found, or the x-coordinate of vertex can be found by using the following relationship. X is equal to negative b over 2a. And so when you write your equation in standard form, you see your coefficients a, b, and c of the decreasing powers of x. Okay. When you look at that, the a value and the b value come into play to find where the vertex is located. And so for this equation right here, this function, if we wanted to find where is the vertex, what we would do is we'd say the x-coordinate of our vertex is located when we plug in, and you'll always take the sign with it. Here's our b value. So minus a negative 4 over 2 times, and what was our a value? Is that a value of 0? A value of 1, an unwritten 1. Okay, so when you look at this, the negatives cancel, leaving 4 over 2, which reduces to a value of 2. So your x coordinate of the vertex is at 2. Wherever your x coordinate is going to be for that vertex, there's also going to exist a vertical line of symmetry. And so by finding what the x coordinate is here, you're going to find that at x equals 2, you have this line of symmetry. So your U-shaped graph is going to be mirrored across this line. And so that's what this line of symmetry or axis of symmetry refers to. Okay, and so once you find what the vertical line of symmetry is, or the x-coordinate of your vertex, you now have to identify what would the corresponding y-coordinate be for that. Okay, how do you think you'd find it? What y is? So you find your x-coordinate first by using negative b over 2a. And then once you have that value, you're going to plug it into your function. So does everybody understand if I wrote it this way? Y of 2. Okay, you're simply going to take your x-coordinate and you're going to plug that into your function and evaluate it. Okay, so what is 2 squared? So we get 4 minus, what is negative 4 times 2? We get minus 8 and then a plus 3. And so when we simplify this, 4 minus 8 is a negative 4, plus 3 gives us a total of negative 1. So here's our y-coordinate. So we can plot our vertex. Okay. Once you plot your vertex, so our vertex has the coordinate 2, negative 1. I labeled it below the point because, very similar to what we did with absolute values, we can determine whether this graph opens up or down by looking at the a value. Okay. So if a is positive, then your graph is going to open up. If a is negative, then your graph is going to open down. So in this particular case, we should label the vertex below the point because we anticipate this graph, since it has a positive leading coefficient, is going to open up. Okay, so in order to sketch this graph, the vertex is the key point. You find that first, and then you need to find 2 more points, one on each side of this axis of symmetry. And so what's the easiest point to find in this graph? When x is 0, right? So if we let x be 0, which is our y-intercept, let's just find what our y-intercept is. So our second step here is find the y-intercept. Okay, and so when x is 0, what does y equal? When x is 0, we can disregard each of these first terms and just look at the last one, the constant 1, 2, 3. So here's our y-intercept. We can label that point 0, 3. And so just by picking this point and finding the vertex, we can draw in half of our graph. So half of our graph is going to look like the following. It's just a U, okay, opening up. Okay, the fact that we have this axis of symmetry means that the other side of our graph is going to mirror that. So it's just going to be the other side is mirrored completely across. Okay, and so if I ask you, which I will ask you to, if I'm asking you to sketch the graph of this, I'll ask you to label 3 points on these. I expect to see the vertex. I expect to see the y-intercept. And then the third point, easiest thing to do, is just label the point that's directly across from the y-intercept. And the way that you can label that is just use, almost like you're doing slope, just use how does it change from the vertex to this point. Our x's change how? We go over to the left how many places? 2. So we're going to move this over to the right 2. So 1, 2. So this becomes a 4. And then we moved up how many? From negative 1 to 3 is up 4. So we're going to move up 4 here. It should be the exact same y-coordinate, right? And so you get the point 4, 3 as your additional point. Okay, and so just by finding the vertex and then labeling the y-intercept and mirroring that across, you get all 3 points and you're able to sketch your graph pretty quickly. Okay. The only time where you have to choose a different set of points than the y-intercept and its mirrored corresponding point is if your vertex lies on the y-axis. If that's the case, then that is your y-intercept, so you just have to find another set of points. And you can choose any that actually fit. You can just pick a value for x, find the corresponding y, and then move to the other side of the graph as well.